Julia. So nice to see you.
Hello. Well,
Lovely. We're glad to
finally.
join us. That's awesome.
Yeah.
We are just about to get started here. So welcome, everyone. We are doing our fourth session for our new grade 5 math. And so we have one left to do after this, and that will be kind of to wrap up the year. But right now we want to move from where we left off in session 3. I'll talk a little bit about that, but not a lot, and how we'll transition to the last one, because just touching base with a few of you already to see where things are at and how things have been going. Want to make sure that we give you enough time to sort of stay on pace with where we're at right now. So my name is Krasarski, for those of you who are new to us, and it's my pleasure today to unpack sort of the next 3 months. I know we're in February, and we already touched on February in session 3. We even touched a little bit on March, so some of it will be a bit of a review. If you weren't here, then you're hearing it for the first time. But also how far we said we would go into April, because we're back again in April to look at May and June. That's kind of how we've been doing our sessions and moving forward with them. Okay, so in the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse First Nations, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to its original peoples and the story of creation of this country in a way that history has forgotten. And I am coming to you from Treaty 6 today from Camrose, which is where I have my home office. And I'm not sure why this isn't showing up, but down in here there is a link. So I'll fix that before I send it out to you, just to darken it up a bit. But just always within our acknowledgement, we're trying to build in some information in there that might help either infuse math into your lessons from an Indigenous lens, or to give you some direct lessons through that. And there's both in this particular link that I think you will find helpful. Okay, so where are we at today? Kind of what we said we would do from session 3 to where we're going to go. We are going to look at fractions, because that's where a lot of people are right now. You're kind of moving into that improper fraction, dealing with fractions, decimals, percents, like having that conversation just started. It really gets unpacked in grade 6. So we're going to look at 5 and 5, just a little bit on, again, the interpretation of an improper fraction. We will go back and have a look at how money, one of those coins in particular, can really help solidify that for us for students. But again, if you haven't been doing money, then this would be a first time round for you to maybe introduce that and to get that into your math program as well, not just as a financial literacy piece, but as the tool that you're teaching the math with, more so. Looking at adding and subtracting fractions, remember in grade 5, they do that with the common denominator. And so how do we interpret that, and how do we get that from all of the emphasis that we've had so far on unit fractions, which starts in grade 2, big emphasis, to where we're going to be, and how do I leverage that for adding and subtracting? Talk a little bit about ratios. Again, we'll unpack that even more in April, but we'll start on 5 and 7. And then we will look at algebraic expressions. We had done the numerical ones already in session 3. So now we're going to unpack the algebra side of it. And we'll touch a little bit on the solving of equations. But what I'm finding is that most people aren't ready for that yet. So we're going to leave the actual solving of the equations for April. So pretty much all the grades are doing that component in April. That'll be the very first thing we start with. And then I've got a section in there, estimating area. It's an activity. It isn't another lesson. We already did in session 3 the actual area and perimeter, and that a rectangle with the same area can have a very different perimeter. We did that one in session 3. So if you're starting that, you might want to go back and have a look at session 3. But we're going to just talk a little bit about an activity that I'll share with you. It's another slide deck, and you can just use that slide deck if it helps you. And then also I want to, I've just put this in because a few people have been emailing and asking about, these big numbers that the kids are supposed to know. And Not really sure how to model that for them other than just counting, like what does that look like? So I'm going to share a site that you can go to, first of all, have them engaged in finding some big numbers and maybe just a little bit of practice for all of us, even as adults, what an abacus can do and how I can model numbers and how I can add big numbers with that as well. So that'll be kind of our end piece to our session today. So we have looked at February. In session 3, we kind of unpacked that a little bit, but we also said we would pick up a few things as we go along today. Looking at March and April, and again, we are going to be coming back in April to meet again. So the solving of equations pieces will leave some of that heavier stuff for that one. But you're seeing that a number of our outcomes have already carried over. So this isn't going to be kind of the first time that we're seeing them. So when we look at 5N5, that was the interpretation of improper fractions. So that's one of the things that we'll talk about today. You have seen that before too, if you were with me in session 3 and actually in session 2 when we were counting by unit fractions, we'll show you a template that you've seen. But again, if you haven't used it, now would be another time, or even if you had used it, now would be the time to bring it out through the lens of improper fractions. The N6 is the common denominators, adding with fractions. And then when we look at 5N7, which is that April time, we're looking a little bit at ratios and what ratios are and how do we put those in? How did that tie into fractions? And it very much does, but it's the interpretation and it's definitely more context-based. So again, we'll have more examples of those to pull forward. Getting these 5N5 and N6 behind us and really making sure that the students are strong in those makes getting to 5N7 fairly simple and fairly easy, but they have to have a good context of what that is. And then fractions, decimals, ratios. I did put that one into this lesson so that we can do more context questions of ratios when we come back in April. And then you see that we also did start the A12. We did talk about algebraic equation or expressions, but we really didn't define a whole lot. So today we'll go through and define those pieces, the terms that go along with it, and what would that look like, and how might I introduce that to students who haven't seen it. And if you're a 5-6 teacher, you definitely are going to have to start at the 5 level because they won't have the language or the terminology in grade 6 this year. They just didn't pick it up last year. So you would want to start with everything we're doing today. You want to pick that up. Won't take a long time. It's not like it's going to put you back 2 weeks or anything, but you can't really move ahead with grade 6 until they have this part behind them. So that terminology that's in there, knowing the difference between an expression and an equation, those types of things are the things that we'll look at. So maybe some conventional ways of evaluating. I would assume that if we're into 1.2, that they've already done or are working on the order of operations. They kind of go hand in hand, and you can't ask me to do an expression or evaluate it if I don't understand what the order of operations are. You can tell me what to do, but that won't solve the problem for me when I have to do it on my own and try and figure out what the correct order is. So they should already have done or are doing, they can do it at the same time, the order of operations as they're going through this. And here's where we're going to talk about solving equations. We're going to look at, we can interpret them, we can absolutely evaluate them. We'll do the evaluation part, but over here, we actually want to solve some equations, expressions and equations. We want them to know the difference between the two. So let's start with 5N5, right? And this is the specificity of 5N5 right over here. So it's talking about what fractions were, again, that they represented quantities. In this case, our focus is on what's an improper fraction. And again, it could be as simple as you saying, and I'm saying simple with tongue in cheek here, to be honest with you, if you just telling me that an improper fraction is a fraction with the top number being larger than the bottom number, that's true, but that's just info. That doesn't mean I understand what you're asking me. It would be better if you had already taught me what a unit fraction is. You've taught me how to count on a number line with a unit fraction. And for me to count my way into an improper fraction makes much more sense. And that's where some of our coins do a better job of teaching that piece. So I'll show that to you as well. And so I'm actually going to take improper fractions. I'm going to talk about the fact that we can have mixed numbers, that they can be interchanged. And we're going to do them kind of at the same time. And I'm even going to bring in that notion of, from the other outcome, the ratios, the fractions, decimals, and percent. Like I'm just going to bring all of these because they all tie together. This is not really a curriculum to say, we're going to do this box, we're going to finish this box, now we're going to move on to the next box. They really connect, and we need to keep connecting them over and over and over again to make it understandable for the student to say, oh, you taught me improper fractions because I needed to find a mixed fraction, and I needed a mixed fraction in order to be able to find maybe a decimal number on a number line. That's part and parcel of what they have to be able to do. So always coming back, moving forward, backwards. It isn't about saying, I'm going to do 5 and 5. And as soon as we're done 5 and 5, I'm going to 5 and 6. That may not work out well for you, and it may not make the connections that you're looking for. So it's really important that the students have a context for an improper fraction. And that word context can't be overemphasized. We've been saying it all year. Give me a context, a story, a place for me to connect what you're asking me to learn in these outcomes, the way they're phrased, so that I can get what it is that you're actually asking me to solve, to break down, to put together. So those are the pieces that we are continuously harping on, saying, where's the context that the student might see? Money is an easy context. And I know for those of you who've been with me all year, you've been saying, here she goes again, money again. But it is. Money is an easy context, and it's real. And it's something they could walk around with in their pocket. It's something that they might have in a savings account. They might have a part-time job. They might get an allowance. Like, that's real. I can leverage that to teach a lot of these concepts for the students. Okay, so let's have a look at just a quick sort of column that's been put together for you. And the only reason I put this together is a lot of people have asked about, this unit fraction idea. Like, where is it coming from? It's not Chris's idea. It's coming from your curriculum. And it's saying right up front, make the whole from a unit fraction. That word unit fraction is coming up over and over. And even when the word isn't there, it's implied. So we really need the students to understand that. It isn't a one-off, one lesson about a unit fraction. We really need them to understand, how do you find it? What does it look like? How could I put it in a number line? How can I add them together eventually? That's what we're going to do today, to get another fraction that's on a number line. How can I use that for counting? Money was one of them that we used, using the denominators of the dimes and the nickels and the pennies and the quarters. So we're using those kinds of pieces in here to try and leverage and build off of those. So when we get into grade 5, we see again, fractions with common denominators are multiples of the same unit fraction. So if I don't understand what a unit fraction is, and by understanding, I'm saying, don't just give me a circle that's been divided into 8 pieces and you say shade 1 in, and then what did you shade in? 1/8. True. But quite frankly, who cares? That just means I can count to 8 and I know how to color, but that doesn't mean I understand what a unit fraction is. So what does this have to do with counting on a number line? If you taught me in grade 1, 2, 3 to go 1, 2, 3, 4 on a number line, and I can skip count by 2s on a number line, then I should be able to do the same thing with unit fractions. So it's important for us to spend that time and just keep revisiting. Same thing over here when we talk about multiplication in grade 6. We are talking about multiplication is really just the repeated addition of the unit fraction. So we should be able to give them any fraction. They should be able to give us, what number did we multiply the unit fraction by to get the one I gave them? So if I gave you 7/111, I would expect that you would know that that fraction came from the unit fraction of 1/111. And because it was 7/111ths, I multiplied 7 times 111. That's the breakdown. It should be fluid back and forth for them to be able to do. Okay, so we have said this before, that we need to stop kind of just jumping into fractions and telling saying, here's the numerator, here's the denominator, this is what it is, and let them experience a lot of that finding out on their own. If we read the verbs carefully in our documents, they also say investigate and explore and determine and describe and explain. That does not mean stand up and deliver. That means they're doing a lot of that work. So we really need to get that kind of piece happening for them. So just kind of staying away from this format until it's necessary, and obviously unit fractions, we need it, or just telling me what the top and bottom numbers are is just kind of backing off from that. Eventually, we want to make sure they know that. But we're more important that we want them to understand that the fraction is a relationship between two numbers. And that would bode well for when we start talking about ratios. Ratios are also the relationship between two quantities. I might say the number of boys in the total number of students in a class. That's a relationship of boys to the total number in the class, or girls to the total number in the class, or the ratio of boys to girls in the class. So it's a relationship between two quantities. That's any fraction. It just hits home a little bit more when we put it in context for a ratio. So a fraction is a number that tells us about a relationship between two quantities. They should be able to talk to us about those two quantities. And if we take sort of our same idea that we used to do with our base 10 blocks, still not saying don't use them, saying until I understand how to use the money properly, then the base 10 blocks will make more sense to me. But when I start moving into decimals, the base 10 blocks don't do me any favors there, because it's harder for me to get big numbers and have a decimal when I changed the rules of what a flat was to get those decimals working in a base 10 system. I don't have to do that when I deal with money. If I have pennies, dimes, those are base 10, 10 of these to give me a dime, 10 of these to give me a loonie, 10 of these to give me so on. So there's your base 10 system without having to change the rule. This also gets me to the decimals and the fractions that I want to talk about, etc. So we had, and again, some of you have seen this before. We're not going to build this. We've done this before. But we took our quarters, we took all our coins, but we put the quarters onto a number line that was made out of hundreds, and we just said, put cents behind it. There's your context. You could have put dollar signs in front if that's what you wanted, but we're talking about 25 cents. So we're talking about 100 cents makes the whole 100, which also happens to be one loonie. I have 4 quarters that make up my 100 cents. And that quarter is kind of the unique coin, because not only is the name of it what it is, it makes it easy for me to see quarters, and quarters are something I can take a piece of paper and fold into quickly. That's a visual I can create for kids easily, and that they can create on their own. Even with a scrap piece of paper, they can come up with what a quarter would look like. So as we go through, we want to make sure that they can read any number line with unit fractions, right? That's going to be important. So if you haven't done that work with unit fractions, or really deliberately shown me as the student, how do I figure it out? Then what I need to do is just like I taught them how to figure out where to put 1, 2, 3, 4. Now we have these values in between, because we're going to get to decimals and mixed numbers. So the number of tick marks gives me the number of spaces that's going to be divided. So 4 tick marks would give me 5 parts from 0 to 1. And these are always going to be equal parts based on what we're going to be teaching them. So that makes this 1/5 of the distance to 1. So that's an important unit fraction. So they should know, give them a whole bunch of blank number lines where maybe you put the 1, 2, 3, 4, it doesn't matter, but it would be helpful if you did, so that they figure out what's a unit fraction that you want me to look at. In grade 3, in this new curriculum, they would take unit fractions in the imperial system. And remember, the imperial system was based on fractions. So once we went to metric, we kind of lost some of this stuff, which was second nature to most students. But to have a quarter, an eighth, a 16th, a 32nd, those are very common fractions that I would find on an imperial ruler. And they're expected to be able to find those by simply counting the number of divisions. So your students obviously didn't do that because they didn't have that in grade 3, So we do need to spend a little time, if you haven't already done that. How do I read a number line to find the number of divisions for the unit fraction? I could also, and I would hope, not just give me the number line, they give me something tangible that I can also do. Maybe I take Cuisenaire rods. Okay, Cuisenaire rods, here's the orange rod. If I say the orange rod is a 1, not a 10, a 1, and each one of these is one of the red. And we said that originally the orange was 10, a red was 2, 2, 4, 6, 8, 10. That gave me 1. Well, now they're going to be decimals or fractions of that. We also said that if I wanted to write the unit fraction for an orange rod, one of those reds was representing 1/5. So I could show them this in terms of Cuisenaire rods. I could build another one to get to 2, and then they would see that there are 10 1/5 to get to 2, and that there would be 15 1/5 to get to 3. And then I might have some in between so that they start to connect that the total number of fifths, the total number of reds, is actually getting mapped up here as they're counting along. Or on top of the line, and this is what I personally would do, is I would have them count by 1/5. Well, the first rows, the first part's done for them. But then we would go over here and we would have, this would be the next 1/5, so that'd be 6/5, 7/5, 8/5, 9/5, 10/5, so on. So I'm matching the number of reds, I'm counting by 1/5, I get the visual. I'm also seeing that I could reduce those into a mixed fraction, and we can talk to them about how that's going to look and why that looks the way it does. So if you need virtual Cuisenaire rods, I have the link right here. Or if you have them in class, that's even better. The more that they can do them just hands-on, the better that would be. So in this case, if I showed them this, based on what we were doing up here, here's my 1, here's my 2, here's my 3, here's my 4, okay? I can see that I had 1, 2, and a little bit. I don't have a whole amount here. So I have 5, 10 plus 3 is 13 1/5 or 13/5. And some students will write 13 bracket 1/5. So they'll write them like they say them, 13 1/5. 13 1/5 is really the same thing as a 1 plus another 1, which is 2, and 3 of those 1/5. So now I can connect how I got to 2 3/5. I can see it visually. This is not a race. You need to give them lots and lots of these. And as simple as you might think it is for some of our students, that's kind of mind-boggling for them, and they get stressed. But if they can play with the manipulative at the same time, they can count it out. Those counting by 1/5 makes more sense to them when they can touch them rather than just write them on top. But I would have them write them on top, put them here, show me something underneath, whatever works, okay, whatever they like to work with. So if I think about this now in terms of, I need to be able to put a number, and in grade 4, they do up to hundredths. In grade 5, you're doing thousandths, so 3 decimal places. How do I put this on a number line? And that's where we lose a lot of our students. They look at the number and say, I don't know where decimal 26 goes. But strangely enough, if I say to them that if I change these now just between 0, 1, 2, 3, and then you give them some benchmarks in here, if I say that this is $1.26, all of a sudden, that seems to not be such a big obstacle anymore. $1.26. Okay, well, it's not even halfway to get the next one. It's just over a quarter. They start to put those together all on their own without us prompting them about where it should go. Again, I could be talking about 1/100, or I was counting by tenths and then pennies that went onto it. So that's where the money makes the difference for the student who just gets lost in the number part of it. If you give me a context, then I have a fighting chance of being able to get there. So again, if I understand then how I got to each one of these, and maybe we didn't label them all, maybe we just gave them a couple, maybe we even gave them one, maybe we just gave them 1/4, and everything else is blank and they fill it in. Or we give them 3/4 and we give them 1 1/4, you fill in the rest of it, right? So that depending on where you're at with them, if they've done mixed already, or if they're just counting on tops, however, wherever they're at, once I understand how to count by the unit fraction repeatedly over and over and over again, then I should be able to answer any question like this. I should be able to tell you when there's a number between 2 and 3. And better yet, when you have them stacked, these are called stacked number lines. Then it's not always in twos, they could be threes and fours, but two is easy for us on the screen right now. When I see them stacked like this, it also lets me not only see that they can count by the unit fraction, but now it becomes a little bit more obvious to them too that as this denominator, I wouldn't tell them that, that's one of the things they have to discover in grade 3. So we give them a little time in grade 5 to figure that out too. But the larger the denominator becomes, the smaller those steps are, because I'm dividing that 0 to 1 in a whole lot more pieces. So the pieces are getting smaller. So the larger the denominator, the smaller the hop is going to be. And so when I say, can you find me a number between 0 and 1? Well, they might say a half. But then they might also realize that, oh, well, this is like $1. If this is $1, this would be the same thing as saying I counted by 20 cents, another 20 cents, another 20 cents, another 20 cents, another 20 cents. So here's 20 cents, here's 40 cents, here's 60 cents, here's 80 cents. Well, you change it like that. Now I can say, oh, well, the number between 0 and 1 could be 85 cents. And if I know to write that as 0.85, I've got it. So it's that connection back and forth and making it really obvious and deliberate for them that we can start to put things like this into the number line. So this is the one that I was referring to. We've seen this before. We've used it on several occasions. But again, you can just download it. In session 3, there's actual link in here that you can just take it off. But we just said, we'll do the first one with them together. Start small. Say 0 is on the left and 1 is on the right. Make it easy. That would be grade 4. So 0 on the left, 1 on the right. That means I had one hop here and another hop. So this is 1 over 2 hops, and this is my second over 2 hops, or 1/2 and 2 over 2. Now we'd expect them to figure out what are the number of hops they have to get into each one of these. What are the unit fraction that's being counted on each of these lines? When 0 to 1, common length, that is grade 4, because grade 4s do not do improper fractions. So this is what it would look like. And like I said, some of the students will write it like they see it. This is my second quarter hop. This is my third quarter hop. Or some of them just write it like this. Either way is fine. In fact, this is even better because this is grade 6 right here that you're doing. They don't know that. But anyway, I've got these 0s to 1 and I'm counting. And you could give them other ones. I'm just giving samples here. I'm not saying that they have to be those. But now I could even compare. Like, what do I notice about the halfway mark? Well, I see a half. I see 3/6. I see 4/8. They did equivalent fractions in grade 4. They started it in grade 3, but grade 4 is the big one. So they should be able to recognize that. So again, if the grade 5s are a little bit weak in it, this is a great one. Grab a ruler, grab the edge of a book, put it down the center, and what do we see? Are there any places that are the same as 1/3? Well, yeah, if I go down, I see 2/6. So they could start to find, kind of like your fraction strips, what are things that are equivalent to each other that are on just this sample that we built. But grade 5, we don't want necessarily all ones down the side. We want to give them opportunities for improper fractions. So we shifted the 1, and we have done this one before already. So we shifted the 1, which just means I'm going to still have to recognize what am I counting by. But this time, here's my whole right here. So here's my half. Here's my second out of 2 hops. Here's my third, 3 over 2, or 3 1/2 hops. So this gets them into improper fractions. And then we can have that conversation about, well, what did you notice about the numerators of all these ones after you passed 1? Well, they get larger. Correct. So we're saying that 3 out of 3 is what I need for 1. This one had more than 3 out of 3. So that would be like saying I have 1 and I have an extra 1 left over. So there's my 1 and 1/3. So just rationalizing and talking that through with the students will help them. But remember that I said the quarter was kind of the magic one when it comes to really solidifying things for you in grade 5 and in grade 6 as well. That would be one that we're going to unpack here right away. Here's an example of where I might say, now that you've known a little bit about skip counting by 5s, can you find where these would be housed on this line? So can you put them where they belong, or give them any other one that you've been practicing on? multiple different ones. We want them to really get an understanding of what that looks like. What numbers belong to each missing value? So now I'm not giving you 0 to 1. I'm saying here's 4, here's 5. Does that change how I would figure these out? And the answer is no, not really. I still need to figure out how many times have I been divided. I'm going to be counting by that unit fraction, but I'm just going to be adding it to 4. So it'll be, I've got 1, 2, 3, 4, 5, 6, 7, 8. So this is 4 and 1/8, 4 and 2/8, 4 and 3/8, and so on. So can they figure out that that counting isn't going to change? It's just, it might have a lead natural number to it as well as a mixed. So when I talked about the quarter being kind of our magic number, it's easy because when I see I have 5 over 4, I have 5 quarters. And that's the name of the coin really does help me to understand what I'm saying. So I can get 5 quarters and put them in their hand and say, how much money do you have? Oh, I have $1.25. I have $1 and 1/4. So I start to unpack with that magic little coin the actual things that I need them to see. And again, it helps me to change this to a decimal just because I'm writing it in terms of money. So that's a good one to get to. The dimes work as well. We can also have the 50-cent piece. It's just the 50-cent piece, you don't see it. It's still made, but you don't see it very often. So you're better to do it as the virtual money and have that one enabled in there so that they can bring it out so they can see here's a $50, here's another $50, here's another $50. When I put these together, that gives me 1 and 1/2 dollar. So I end up with a loonie and 50 cents or $1.50 or 1 and 1/2. So there are some coins that just make it a little bit easier. All the coins work, but this one just makes it easier for us to see and quicker for us to do. So when we start looking at how we can break things down, we also need them to understand that for every mixed fraction, there's a whole part, and then there's the part that was the fraction part, the part that wasn't the whole. If I think of this as money, this is the dollar amount, this is the amount that's cents and has not got enough in it yet to make another dollar. So it's a way for us to think of how we did part wholes in kindergarten, grade 1, grade 2. Well, this is really what you're saying when you start showing them what a mixed fraction would be. So again, I could ask them to put these values into the right places or explain to me how these values fit on a number line. And then I could even say which one would be bigger, which one has more. So if I understand that the whole number is the same, that really is the insignificant part here. I just need to pay attention. If I have 3/8 or 5/8, in which one do I have more? Well, I have more if I have 5/8. If I had 5/8 of a rectangular pie, or not a pie, sorry, a cake that was cut into 8 pieces, and I had 5 of them, where over here I only have 3 of them, clearly I have way more over here. I can see it down here. And I'm going to qualify. These are the images that we had that were easily available, but circles are not always the best. Remember, circles are not easy for kids to replicate. If it's an even number, it isn't always an easy fold on a circle. So that's where a rectangle becomes a better choice if we have that option. Okay, so we have this kind of conversation that we've been talking about, but 5n6 also talks about composition and decomposition. So it goes to that part whole that I just showed you. It's saying, can you break those up into its unit fractions? And I could even say, could you break this up anymore? And you could have 1 and 3/8 with a 1. There could be a circle down here, which is 1/8, another circle 1/8, another circle 1/8. So I could break them up even more if I wanted to. By the time grade 5 hits, I'm not sure that's where you want to go. This could serve that purpose for us here. This can just consolidate what they're seeing in the blue. But that's really what this piece was talking about. Can the students draw for us a composition or decomposition of a unit fraction from whatever number we gave them? Can they express that as with a common denominator as a sum or a difference? Well, since they were all 8s in this example, this means that I had 8 8s here. I could find it over here, 1 and 3/8. I could say this was 8 8s, 9 8s, 10 8s, 11 8s. So I took 11 1/8 and added them together. That would be one interpretation. I took 11 1/8 and grouped them together and had a common denominator. They're all the same. I created my whole where I could, and then I looked to see what was left over to create my mixed fraction. So again, they need to be able to do that decomposition and express it, right? And investigate. That's like do it, try it out, trial and error, see what you get. They could do it with Cuisenaire rods. So what are the different ways that we can have them do those kinds of things? But adding and subtracting fractions with a common denominator is really where they land in grade 5. They don't do different denominators. So they're not going to do a half and a third. So a half plus a half, a third plus a third, 2/3 plus 1/3, that kind of thing. We can do, those are the kinds of things they can do as long as they have the same denominator and it's within 100. So, and we don't have to get crazy big numbers just because we can. We're looking for numbers that something that they could at least relate to. And yes, there are big numbers that we can use. We could show them an imperial ruler. We can show them that 1/16 plus 1/16 is 2/16 and has a place on my ruler that doesn't show 2/16, it's actually reduced, right? So the equivalent fraction thing. So again, we want to get that kind of conversation happening. When we talk about this right here, this decimal and fraction cards, I won't go into it right now, but I just do want to tell you what it is. This is a game. It's like memory, but it has a variety of different decks. And you as the teacher can decide if you want to use all of them at the same time, or if you want to start small. So I might have unit fractions, and I might have pictures on a number line, like an X on a number line. So if that was all I gave them, and we're going to do it as memory, then I'm trying to find a match for 1/10 that has a 1/10 X on a number line. You also have them as decimals. You also have them as a grid for percents. You also have them as improper fractions. So this is a progressive deck, number of decks that you can just create. The kids love them. And once you finally do get them, just letting them use all of them, the rule that I kind of use is because every one of them has like 5 or 6 different pairs or matches, depending if I'm doing percentages right down to unit fractions. I just say to them, find a pair that matches anything that's a pair, and you got a pair for a point. So you can print these off. Printing them in color is helpful, but not absolutely necessary. So you can have a look at those when you get into them. So again, now when we talk about just counting by a unit fraction, and we're trying to add them together, I can say 1/5 plus 2/5 is just like saying 1/5 plus 2 more of those 1/5 hops. So that's where this big one is, takes me to 3/5. I'm still counting by the same unit fraction, so I can see what that looks like. But this diagram at the top here is just modeling for them that if I have a 1 in front and I say 1 and 1/5, add 2/5. The procedure is the same. Just because I'm further down the line doesn't change how I'm going to do 1/5 plus 2/5, whether I'm at 2 and 1/5 plus 2/5, etc. So that they start to see that there's a bit of a pattern that's starting to grow here. The natural number that sits in front just increases the wholes that I have, but it doesn't change the part that I'm adding together. That hasn't changed. Every one of them was a fifth. Add another 2/5, and I end up with this picture for all of them, only the number of wholes. So again, just having them experience that and using those values would be a good lesson for them. Okay, and then when we talk about the N7, this is where the ratios come in. This is also where a fraction card game that I put in here can come into that. But we're going to revisit this when we talk about sets in April. So I'll give you some context for expressing part-part ratios, which we just looked at. What's a part-part ratio? You might give them something like the students in your class, like how many boys to girls, how many girls to the class, how many boys to the total number in the class, how many people have running shoes versus, I don't know, whatever kids are wearing today. So just getting things that they can relate to in class quickly in a ratio relationship, but showing them that we could write that as a fraction, but then order and naming each part of that fraction is important, right? So if I said boys to girls and the fraction was 17 to 13, then that's 17 boys to 17 girls. That doesn't mean that if I flip it over that I got the right answer, because now I've got girls at the top, and that's not the order that I gave. So in ratios, that order will become important. We will also show them that ratios could be written with a colon in between, but for now, let's just stick to fraction format so that they understand that fractions can represent different things. So sometimes naming that is going to be really, really important for them. So we'll spend a little bit more time doing that when we come back in April. So here's just an example too of where I can start to connect the ratios, the fractions, the decimals, the percentages, the things that we've been doing. Here I see 44 out of 100. If I was doing this as cents with money, way back when we said another way to think of cents is take a flat, turn it over, and there's 100 holes there. There's 10 rows of 10, so there's your dimes. You got 100 holes, that's your pennies. If I filled every one of those holes, I would be able to dump it out and trade that in for a loonie. So for some students, that's the easiest way for them to think about it. So when we talk about percent and we say to them, percent means for every 100. Well, think of it as 100 cents. So if I had 44 out of 100, means I'm not at $1 yet. I'm less than that. So I'm going to represent that as 44 out of 100. But we also have something called percent. When they get a mark on a test or whatever you give them, if we still do that, we have a percentage per 100. So in this case, I had 44 cents. In this, I could say it's 44% of the dollar. I don't even have half of my dollar yet. I only got 44 cents or 44% of my dollar. So this is another way for them to think of the equivalence of percentages, the fraction we write, 100 square, which could be just filling up pennies. Every row is a dime that's filled up. And then where does that fit on a number line? Well, if I think of this as money, I know that I need 50 cents to get halfway. So this will be a little bit less than halfway. It just gives them the context. That's all that this does. So this is another way for them to transition to fractions, percents, decimals. So again, I should be able to take any unit fraction, any addition, and write it as its parts. So here's my whole, here's my part. So you could give them three, give them things that you've been practicing with them, have them come up with one of their own where they give it to a partner has to check it. So just so that they can start to show. And then I would change these to like 2 3/5. 5 7/8. Like just give me numbers that I haven't been working on all the time, and then change those and see how they would break it up. Okay, when we talk about modeling, modeling is another piece. We need students to see what it means when we say adding fractions that have the same denominator. So I need to model for them what it means I can add together and what isn't a denominator or what isn't a fraction. I don't see a fraction right here. I see that this is a natural number with a fraction in tenths. Here's tenths, here's tenths. So if I think of this in a picture form, here is 1 out of 10 pieces. This one would be 3 wholes and 2 of those 10 pieces. Here I have 4 wholes, nothing was left over, and I have this 1/10. So when I'm adding, we also want them to realize that we want to add things that are already the same. Why don't we find those and put them together? So whole natural number parts aren't going to change if I just group them together. So I can take all of my wholes and put them together, and I could find all of the pieces that are expressed with the same denominator, in this case tenths, and put them together. I could take this one and put it over here. I could take this one and put it over here. And then I would end up with all of these wholes plus those pieces. So we want students to be able to model what that looks like, not just figure out the answer. Okay, the answer is one thing, but what if on a multiple choice or on a written response or something like this, they just got a picture and they were asked to break out what that picture could have represented symbolically. Like go backwards, would they be able to do that? So now I can count them. I have 7 and I have 1, 2, 3, 4 tenths. So I could even give them an answer and say, can you model this for me? Could you model it more than one way, right? Is there only one way? Is there 2 ways? Is there 3 ways? Whatever. So again, we can show them symbolically. We just want to do it with the number format, that I'm taking things that are the same. Natural numbers can go together. Parts, that's that part whole. That's the reason we do that, that are the same denominators will go together. And the reason I keep saying that is because what if I had written in here plus 1/5 plus 4/5? Right? Same denominators are going to go together. If I had multiple different denominators, which we're not going to throw at them right off the bat, then I would put those together. So this just shows me symbolically that I know how to put these together. Same with this. What if I wanted you to go the other way around? What if I said you have 21 eighths? So that's like 21 1/8 unit circles sitting on the page. So if I had 1/8, my first question would be, how many do I need to put in here to make sure I have the whole? How many 1/8s will I need to make one complete whole? So if I put 8 in here, that's one whole. If I put another 8 in here, there's another whole. And then I have 5/8 left over that are not a complete whole. So now I have 1 plus 1 is 2 plus 5/8 is 2 and 5/8. So instead of just telling me that an improper fraction, divide it, take the top number and divide by the bottom, which is the routine that we follow, give me the reason why that's working, okay? That's going to be really, really important. Okay, so let's move on. That means that I might ask a prompt question. This is something I'd throw out to you. If I had done the improper fraction and I'm prompted question, what might I prompt them with to get to what I just showed you? What would I phrase to put in that prompt question that gets me from 21/10 to the mixed number that I'm hoping that they're going to have? So just think about that for a second. If you feel comfortable throwing it in the chat box, go ahead and do that. But what prompt would you ask them? What question is going to go in here that's going to help me get from here to here? What do you want me to think about? Or unmute yourself if you feel comfortable doing that.
Maybe how many tenths?
Yeah. How many tenths for what? What would you say, Alma, to that? How many tenths for?
Yeah, so how many tenths are maybe on the 21st?
Out of the 21 pieces? Yep.
Yes. Yeah.
Okay. Yep. That would be one prompt for sure. Anybody have a different prompt that you want to put in there or think of? You might even want to ask them, how many tens do you need to make one whole? Like, what would it look like? What would a whole look like if I had 10 pieces? So in this case, every 10, getting to where Elmo was going, every 10 gives me 1. So the 20 would give me 2 wholes, and I would have 1/10 left over. So just getting them to think about, when I look at that denominator, how many of those will I need to fill a whole? How many of those will I need to fill a whole? And what would be left over in the end? Because eventually they're going to just look at it and go, oh, I know what that is. It's 2 and there's 1 left over. Perfect. I mean, that's where we want you to go, but we want you to understand why you went 21 divided by 10 and you had 1 left over. Why is that working for you? So they should be able to model any fraction you give them that's improper and give you the reason how they got to the mixed number. That'll be important for them to know. So here's an example of a sheet that you could use. I mean, you don't have to use any of these, but this would be one. How many groups of 9/9 are there in 21/9? In other words, this is what? This is a whole. How many of those are inside here? Well, there's 1 for sure. And if I take that away, there's still going to be another 1 left over. And then I still have 3/9 left over, which then I can also reduce if that comes down to it. So we're always getting them to think about how many wholes there will be. So to get to, like Alma said, the 20/10 is the 2 wholes that they were looking for. I had 1 left over. So this would be a prompting kind of question that you might ask them. And then you could pick, these are easy fractions for them to practice on. And then pick those bizarre kinds of things, like do one that's got an 11 in the denominator, not that we'd ever use it, but just coming up with something like that. So in the end, we kind of want students to be able to make those connections between the decimal, the fraction, the value of a percent. And if I know how to change a decimal or a number out of 10 to 100, then I also can change it to a percent. So if I change this in terms of money, these are 5 out of 10 dimes. That would give me 50 cents. 50 out of 100 is 50%. So the context alone of money makes a bit more of a connection for some of our students. Will they always need money? No, they don't. But just until they've got it, that's the piece we want. And now I can say, what would go in between? Is there something that you could put in here? Where would you put, what could you put between decimal 3 and decimal 4? So decimal 3 is the same as 30 cents. Decimal 4 is 40 cents. So what could go in between those? That just giving that context helps me to think about what decimal I might write in there that's going to sit in the middle, and what fraction could sit in between there. So again, here's just a sample that they could fill in the blank, something like that. They put their tick mark on the number line where they think it belongs, and so on. So another way to think of this would be if you're just going to use the flats, then 1/10 would be one of those rows. If I think of this as a dime, there's my dime right there, one complete row filled out of the 100 cents or the 100 holes. Okay, so let's finish up with looking at algebra. So in grade 5, and this is done by my partner at ERLC, Betty did a beautiful job on putting this sort of little schema together for us. So I really wanted to use it in here so that you have it, and it's just a quick reference more for you. But we've already done the numerical part. This is the part that we want to get into today. We want to make sure that they understand the difference between this is all numbers, to over here, algebra now has variables in it. So we need to be able to define some of those terms for them and with them, okay? Not just tell me, I need to find a way to get to those and make it understandable. So in grade 5 is where they define all of the terms that go with an algebraic expression. By the time they go to grade 6, it's assumed they already know that. So this year's grade 6 teachers have to go back to grade 5 and do this work with them. So we want to talk about variables. We want to talk about a constant term. We want to talk about coefficients. And then when we get into April, this is what I'll leave for April. We're going to get into the equations, and we're doing inverse operations. Now, for those of you who have done grade 6 or 7 before, especially grade 7, you know that we have integers. Well, in grade 6, they do know positive and negative numbers, but in grade 5, they do not know negative numbers. So this inverse operation, you have to be very strategic about what you're going to use in those questions. So I'm going to make a suggestion of where you could get them to by April, and then we'll use the algebra tiles so that they see them, but we'll limit it to the inverse operations that a grade 5 student can do in the absence of knowing what a negative number is, because they haven't done that yet. So when we look at kind of all the things in algebra, because remember, algebra only starts in grade 3, and Betty did this one as well. She did a great job on this. So just a quick summary of all the things that happen in algebra in grade 3 that they need to know. And again, this gives you a chance to look back as a teacher and say, yeah, we got that, or maybe have to go back a little bit and have a look at that. Here's the grade 4, where we talk about the order of operations, and they're not doing parentheses. Parentheses happen for you in grade 5. And then by the time they get to grade 6, then they're doing exponents as well. So with the operations. So we're talking about all the terms that go along with an algebraic expression. An expression does not have an equal sign. It's not left side equals right side per se. And when we talk about different forms of algebraic expressions, we want them to have simple operations. Sometimes it's just a single term. Sometimes it's 2 terms. Sometimes it's a division. So we want them to be able to see and manipulate those as needed to their ability in grade 5. It's limited to 1 or 2 operations. And again, like I said, we're going to have to be very strategic, because they don't know how to add a negative number to a positive number and get a 0 pair. That doesn't exist in grade 5. That's a grade 6 concept to teach. And then verifying means, have you in fact got the right answer? Can you prove that left side equals right side? And we'll do more of that when we do the equations. So really, this is the piece that we want to really unpack right now is, do they know the terminology that goes with it? Can they do maybe an evaluation of an algebraic expression? So we'll look at one of those. But then when we get into preserving inverse operations and solving, we'll leave that part for April. When we come back, that will be our starting point. And there's no rush to get to that because they really have to be strong in all the other stuff of this algebra first. So here's the terminology that we want: variables, coefficients, constant, an expression, and an equation. So the equation is the part that we'll leave for April. But these are the parts that they're already used to seeing. They've actually done equations, numerical equations, where 10 equals 10, and that could be 8 plus 2 is the same as 6 plus 4. Those are equations, and they're numerical. There's no variable in them. And you prove that left side equals right side, 10 equals 10. So in here is another slide deck for you that you're welcome to use. And what this slide deck will do is just step you through some of the sort of the pieces that you might want to use in order to introduce this idea of variables and algebra. Some of our students are going to hear algebra and go, oh, I heard about that. It's really hard. You know, it's like it's in their genes or something, but it isn't. I think it's all in how they get introduced to it. If it gets scary and, you know, we say right away, oh, I hated this when I was a kid. And we just kind of want to just give them that chance to go at it and have a little bit of fun. So when I start with this is the slide deck I used with grade 5s, and I use it with grade 6s who haven't done this before. So when I look at this, I just give them a bunch of pattern blocks. Just take a scoopful and put them on their desk. Everybody gets their own, or partners or whatever. And I just say, you know, whatever's on your desk, how would you sort them? So let's say that those ended up on your desk, then you probably are going to put things that look the same and are the same color together. And where I'm going to is exactly how variables work in algebra. That's how the premise of algebra is. That's how it will be when we get into polynomials. Same thing. So I put all the yellow hexagons together, and I just ask the students, why did you put them together? Well, they were the same color, they were the same shape. Excellent. That's kind of what we're looking for. So when we look at them that way, we can say they have the same shape and the same color. And when we talk about terminology in algebra, we talk about like terms. These are like shapes for all the same reasons. They have the same color, they have the same shape. So the hexagons go together, the trapezoids go together, the rhombus go together. So what does all that have to do with algebra? I might say to them, does anybody know how to figure these out? And usually by grade 5, 6, they look at you, roll their eyes and say, really? And I'd say, did you guys know that you were doing algebra in grade 1? And they just look at you and say, no, we didn't. I said, yep, if you did 4 plus 7, you did algebra in grade 1. So you learn to add two numbers together. You learn to subtract two numbers. That's algebra. But I could make just a small change to this. Like, what if I took one of them away and just laid an open box? Instead of putting the number there, what if I just put a box there, or a box here, or a box here? Now, what number goes in the box? And they'll call numbers out. They'll say, well, it could be 2. No, it could be 4. Right. It could be anything. Anything you want me to put in there, we could put it in there and we're going to get an answer. So this box just means that it opened up the possibilities. And that means it has lots of variation to it. And that's how we introduce that term variable. A variable is like an open box, like a cup that they used to use in grade 3. I can put something in the cup, and whatever I put in there, I can add or subtract whatever I'm supposed to do and tell you how much I have in total. So a variable is like an open box. It allows me just to put it as a placeholder, because boxes are kind of tedious to draw all the time. But a variable is easy. A variable is a letter from the alphabet. As an FYI for teachers, whenever we do algebra and you use variables, variables are always lowercase and they're always italicized, so that they learn the difference between a variable that's a math variable versus a letter of the alphabet. So it's lowercase, italicized, so that they can quickly identify them. And so here I just replaced it, but called it Y. And then they'll say, are those the only 3 letters? And the answer is no. You have 23 other letters in the alphabet. You could use any letter you want. It would not matter what letters you use. We can tell them later on, especially when we do the equations. We do this in April. We can say that typically we like to use the letters X and Y just because it's a conventional, easy letters to use. But could we have just always been using S's and M's and T's? Absolutely. I mean, it wouldn't matter. It's just we all kind of had to land on something that everybody would agree on when we use manipulatives, what they're going to be called. So this is the sort of the convention that we use, but they could be anything that they didn't need to, that they wanted to have. So these are all examples of what we call algebraic expressions. They have a variable, they have, in this case, a constant term. They don't have to have, though. They can just be a variable. They could just be a number. So we start to unpack some of the pieces that we need them to understand and see. So a constant term is a number. It's never a letter. It's always a number, and it stays the same. So regardless of what I put in for X, this will always be 6. This is not going to change. It's always plus 6, plus 6, plus 6, plus 6. What can change is what I put in for the variable or the placeholder. So variables are generally italicized, and these are the two that we most commonly use. We'll show them why when we get into algebra tiles, and I can show you what the X's and the Y's look like. So here, variables are like the pattern blocks. Again, just to give them a quick reference, you had those different pattern blocks, you put them together. So you put the hexagons together because they were yellow and hexagons. You put the trapezoids together because they were red. Well, the same thing is true when we talk about math and algebra. I want the same letters to go together. I can't take an X and a Y in our alphabet right now and smush them together in my hand and pop out a whole new 27th letter of the alphabet. It doesn't happen. So in this case, I see all these letters on the screen right now. And yes, these are deliberately capitals. I just wanted them to be standing out. So I see all these letters on the screen, and then I might say, they're all variables. Which variables might you put together? Which ones look the same? And so what they will do is they'll go, the M's will go 1, 2, 3, 4, 5, 6 M's. There's 6 M's. That's an important step forward for us because we also want them to learn how to write a variable, especially if there's a multiplication. So they just say it. They will say it. You'll hear it. They'll say there's 6 M's. And I say, well, how many X's are there then? Okay, there's 6 X's. So that step is important. How did they get them? They added them. They touched them or they went up to the screen, whatever they did. But they took all the M's and added them together. They took all the X's and added them together. And I said, well, why didn't you put the M's and the X's together? Well, because they're not the same letter of the alphabet. And one student said, well, one's uppercase and one's lowercase. Great observation. Excellent. You're right. So in this case, when I add these together, I end up with my total, and that will give me, in this case, 6M. How I set it is how I'm writing it. So we teach them then very quickly that how you wrote 6M, 6 in front of a variable means 6 times that number. And the reason we don't put the multiplication sign is what if we were dealing with X's all the time? It would get so confusing to have 6 times multiplication sign and then X's behind it. It's hard to sometimes remember which is the X and which is the variable because not everybody remembers to italicize. So to get around that, we do away with it. And when we have a number in front of a variable, we automatically mean that there's a product happening there. They're being multiplied. So that means how would I write this one? Well, same thing. I could count them up. I see that there are 6 X's and I would be able to write it the same way. So then I can start asking them things like what could go together? What are pieces? And we will do couple together. So I see 4X plus 3 plus 6X plus 6. I need things that are the same that can go together. And they're very quick to say, well, the X's, they could go together. So if I put them here, I could put the numbers together because they don't have any letters. And so that means that I could add the numbers and get 9. I could add the X's and get 10. And if they can't see this, then I take X's and I put them on the screen, 4 of them. And then I'm going to take 6 of them. How many do you see? How many are on there? So just take it back a step and let them do that work behind it. So what they're really doing is they're starting to find the like, just like the like pattern block. They're finding the like letters or variables that go together that they can add or subtract. And I don't always have to add. I can sometimes subtract. Here I had positive 4 and I had take away 1. So adding 4, take away 1. I just rewrite it right here. And so my final answer is 10M plus 3. So this is the kind of work that we want them to be able to get to say that I have an algebraic expression. Every time I have an operation sign in between in an algebraic expression, that operation sign separates what we call terms, parts of. So here's one term of the expression. Here's another term of the expression. Some of them could just be written as 10m. There would just be one term. There's nothing to add or subtract to it because that's all I wrote. If I just write the number 3, that's still a term. I just don't have any letters this time. It's just a fixed number. So I don't have to always have an addition sign in between, but they need to understand how those two pieces fit together. This is my coefficient, the number in front of my variable, which in this case is an m, and this is my constant term. So that just helps to unpack for them the pieces that they need to be able to go to. So that's built in here that you're welcome to use. Oops. So if I go back to your algebra, the very first one we did, these were the number ones. We did those in session 3. In here, they're saying expressions can also be called algebraic if they have variables. And they're asking you to evaluate down here an expression by substituting a given number for the variable. So now if I understand variables, I understand what numbers are constant terms. If I was given expressions like this, and it says that x is equal to 5, well, then that one will just be 5. But what would these become? And we don't typically tell students just write 5 plus 2. Generally, we say to them, put the number that you're substituting into a variable. So this is where the variable was. The x was sitting right here. But I've replaced the x with a 5. So we tend to put a rounded bracket around it to show that that was a substituted value. And now I get 5 plus 2. Here, it's going to become even more important. If I put the substituted value in, now I have a product, and we use the order of operations. We always do that first, and then we do the addition. So it just kind of logically makes it visible for them, the order of operations that they have to do it in. So 2 times 5 is 10, plus 1 would give me 11, and so on. And it would go on like this. Or in this case, it said, can you write an expression that's a division, a variable divided by a number? Well, if x is 5, then this becomes the unit fraction or the fraction of 5/4. So if this becomes an equation, then I can't just throw a 5 in here because 5 plus 2 does not equal 4. So this is what we will do in April. We'll show them how do they get the one answer that is true to make this side equal that side. These are expressions that have unlimited possibilities. Depending on what you tell me to put in, I could have a whole bunch of different answers. Equations have a correct solution. So there's the difference between them. Not only do they look different because you have an equal sign, but one correct solution, several possibilities, depending on what you give me to put in. So we'll unpack some of those, but if they could do work with algebraic expressions, lots of practice between naming, grouping things together, substituting things in, then we're kind of away for when we need to go and do some of the other pieces. So we will do this part in April, but I did put a note here just to remind you that if some of you are working ahead and are still going to go ahead and do that, which is fine, absolutely. Just remember that when we talk about inverse operations, they don't know what a negative number is. So you can't say 2x minus 1 equals 4. I'm going to add 1 to both sides because they don't know what negative 1 is. They can't interpret it that way. So we have to be quite strategic about the operations that we're able to do. To do that understanding, it's sometimes better to do it with numbers first. So I've included, this is a big slide deck. I'm not suggesting you would use it all, and maybe you just want to go through it and have a look at a couple of them. This comes from some of the work that we do or have been able to use from the UK. But what they're showing you here is how we just, if I add a number here to keep both sides exactly the same, if I was just talking about numbers, then I would take 1 away from here so that the total never changes. Okay, and in theory, what are we doing? We're saying a positive 1 add its negative, its additive inverse gives me 0. But really, we want them to understand that for every one I take away or add in here, I would have to take one away here to make sure that they still add up to the same thing. So this slide deck is full of different examples that you can use with students to show them both positive numbers, decimal numbers, there's fractions in here, but we're really just worrying about the whole numbers right now. It's not about variables, okay? It's just really getting them to understand that when I want to get to a balance scale and keep the balance scale positively balanced, whatever I'm doing over here, I have to make sure that I keep things the same, right? So if I take away 340 from that number, I have to put 340 into this number just so that this balance stays flat. Otherwise, if I take away 340, nothing's changed. This isn't going to be 10,000 anymore. That zero should come up when you hit slideshow. So this just gives them a sense of how that's got to work to keep both sides balanced. So this would be an important slide deck to grab some. There's lots in here, way more than you could ever want. But just to give them a good idea of how that means to balance, so that when we come in now and do that with an algebra tile, where we have a variable built into it, they've got an idea of, I've got to keep things balanced. And I can't make any moves happen that's going to throw that balance off. And that's where we'll start. So that's a lengthy one that you can use. It's built into your slide deck that you can have access to. If you are going to go ahead, there is a virtual. If you don't have algebra tiles in your school, you can use a virtual one. This is just one. There's a whole bunch that you can use. It's not the only one. The other piece that comes into measurement, we had measurement show up there. We did all of the measurement parts in lesson 3. This is a screenshot where we talked about, draw as many rectangles that have an area of 12. Well, there isn't just one. There's a whole bunch that they can have. And how do those perimeters compare? So I can have the same area, but the perimeter, the distance around the outside doesn't have to be the same just because the area is. So we talk about that. But one of the things that we didn't talk about was estimating an area that you might see. So this is what I've given you. This is an activity. This is done by, and when you click this on, you'll get a copy to your computer. This is done by a colleague as well, years and years and years ago. But you know what? It just doesn't go away, and it's one of the best things that we could ask for. So when we talk about just estimating, let's say that I look at some of these. I'll go into slideshow here, it'll be easier to see. If I look at what I see here, and this should come up as a grid, I'm not sure why it's not right now, but I have half. This is half, this is half. So a benchmark, remember in the outcome it says there's a benchmark. Do they even know where halfway is? Do they have a visual of what a halfway might look like? So if I were to put this in, I might say to them, using your percentages, okay, let's change it to that, or fractions if that's what you want. How much do you think in percent of this whole square in here have we covered? And most of them is a good guess. They'll say a quarter or 25%, right? And so estimating the percent that's shaded in, it will tell them on the side what the answer is. So give them time to talk, and they can write down their guesses if you want to have some fun with it. You could have them write it as a fraction, decimal, and percent if you want all three of them. So there's lots of activities that you can do here. So what about if I did something like that? So for those of you that are still watching, you might want to look at it and say, just in your bet, you don't have to put in chat box, but just what's your best guess? Just think about it. What would you write down as a percentage? And then there's your answer, 75. So you might be a good estimator, and you might not be a good estimator, right? But practice, kids need practice. What if I take it away from a one big blob and just say, I've got this strip, I've got these two, I've got this one. So again, have they got a connection between how many vertical lines there were? There were 10. What percentage is being covered now? And it doesn't always have to be in a block. So I get 40%. So it goes on like this. I think there's about 10 of them. And they definitely start to tear. There's a piece that gets torn off. So now I have to think a little bit about how much is a quarter, how much more than a quarter would it be? So it's just a good little practice for them to do some estimating. And then the last one was that big number. There were quite a few people that have been asking, and I had done this last year, and so people were asking if we could put it back in again. So an abacus, for those of you, you might use Rec and Recs. Rec and Recs are great because they have 5 whites, 5 reds, or whatever colors you have on yours. But an abacus is multiple rows of colors, and the true abacus has about 10 rows and none of those colors repeat. So in other words, there's 10 unique rows, which is what you're seeing here. You can't buy these anymore. And if you do, they cost a fortune. And why would we? We could use the abacus that is sitting right here. So without going into that one right now, I just want to show you behind this next slide what I've put in here. So for an abacus, you start with a lower number at the bottom, but you can assign it to the students as well. I give them the printouts that I'm going to show you so that they know what each color represents. And if they have to refer to that, I don't care, that's fine. So the lowest number is ones. Next one is tens, hundreds. So you see the place value, right? This allows me to call out a number. So I might say, show me 122,454,000, blah, 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 right? So I can call out a number, and based on what I'm calling out to them, they're going to move each of these beads over to represent that number. So having this legend on their table is helpful, because if they're going to play with these, they need to know what those stand for. So now they can build a number, but I can do number like show me 127. So they can go one of those, two of these, seven of these. And I can say add to that 454. Like they can do simple addition just like they did with money. Now you can do it with this as well. They have to regroup. They have to go back. They have to grab another 100 or another 10 or whatever I need. So I can do that all the way up to big numbers. This is not just paper, pencil, give me 30 drill and kill questions. Same 30 drill and kill questions, only I get to do it with this. Kids are engaged in this. They like having that opportunity to be able to do that kind of work, but they need this kind of a legend. What I also want to say is, as the teacher, because you're doing grade 5, I can change anything that's on the side here. I don't have to say that the number on the bottom is only ones. I could change it because you go to thousands. So here's my third number behind the decimal place, my second number, my first number. This is the decimal. And then I have ones, tens, hundreds. So I can change the values of these and just, I can say now, show me 3,454 and 127 thousandths, right? So now they have to listen to the number. They're supposed to be able to transfer that number into numeric form. Well, here's one way for them to do that. And they can have some fun. They can look over at each other. Do we get the same beads moved over? And if not, who's right, right? Just figure it out. So this is another way then that you could go through and that you can find a way to engage students with big numbers. So when you go to this one, it comes up. You can get rid of all this stuff if you want, just clear it out. And then I usually, if you've used Rec and Recs in the classroom, then I would suggest moving them over, because the rule for Rec and Rec is you push from right to left. So you're always pushing the value that you want them to show you. So the answer will be over here. And then if they have to add or subtract or whatever you want them to do. So just move the whole thing over. And then if I ask them to show me, like this is just hundreds, 127, I could go 1, 2, and I'm looking for them not to count by ones. This is subitizing. Pushing 7, right? So, and then I can add to that whatever I want. So this is a fun way, but a great way for them to take word numbers and put them into a visible form, and then they can write it out. Or you can even say, I'm going to give you 12 questions on a piece of paper. You can use your abacus to figure out the answer. They love doing that. It's the same 12 questions I would have done with paper and pencil. And for those students who really, really aren't into physical manipulatives, they're going to do with paper and pencil, and they're going to be happy to do it. Okay, your last page that's on here is just references for you. So here is the ARPDC website if you need any resources from there as well. Those CPAR documents, they're still continuing to be posted, so always go back and check those. And then I just put these in just to make sure that everybody is familiar with the fact that all those verbs that are in your curriculum have already been defined with exemplars. So if you've never downloaded these, you might want to do that and just have it available, because that way at least we're all using the same sort of language and definition of what those verbs mean and how we might interpret them. Okay, thank you. We are 6 minutes over, and I apologize for that, but I hope that that gives you a good starting point to really get into algebra. so that when we come back, we are able to do the equations. I'm going to stop the recording in case there's any questions.